Have you ever felt like AI has this weird split personality? One second, it's a total genius, solving problems you'd need a PhD for. And the next, it's, well, a complete bozo, failing at something a kid could figure out. So today we're going to dive into this paradox and find out what's really going on in that silicon brain. So, get this. On one hand, you have AI models absolutely crushing problems from the International Math Olympiad. We're talking elite level stuff. But on the other hand, you ask it a simple, common sense question like this one about getting the wrong shoe from Amazon, and it just fumbles. It misses the totally obvious answer. So what's behind this jagged intelligence?
Well, to understand the bozo, we first have to understand the genius. We need to peek behind the curtain. Because it turns out, these incredibly powerful systems are all built on top of a surprisingly simple idea.
It all comes back to a concept from statistics called an n-gram model. Now that sounds complicated, but the idea is actually super simple. The model just looks at a ton of text and figures out which words are most likely to follow other words. You know, if it sees the cat sat on the a million times, it learns that Matt is a really probable next word. It's not about understanding cats or mats, it's just about playing the odds.
And this is where a great analogy from AI researcher Professor Kambhampati comes in. He says we should think of large language models, LLMs, as just n-grams on steroids. That's it. At their core, their one primary job is just to predict the next most plausible word.
So how is that different from something like a database? Well, a database is like a perfect librarian. It gives you exactly what you put in, no more, no less. It can't make stuff up. An LLM, though, it's more like a storyteller. It constructs an answer for you right on the spot, one probable word at a time. It's not retrieving a fact, it's generating a story that sounds right. It is literally designed to make things up.
And this leads to a really powerful kind of mind-bending way to look at it. Professor Kambhampati argues that LLMs are always hallucinating. That's their default state. It's just that sometimes what they make up happens to line up with the facts of our world, and we call that a correct answer. So hallucination isn't a bug, it's the core feature.
Okay, so here's the crucial split. LLMs are absolute masters of style. Why? Because style is all about patterns across millions of examples. So asking it to write a poem like Shakespeare is easy for it. But correctness, that's a whole different ballgame. A fact is either true or false in one specific instance, and that is way, way harder for a system that's just good at mimicking what it's already seen.
You know, this explains an experience a lot of us have had. It's called the Gelman effect. It's that thing where you read a news story about your own profession and you spot all the little mistakes. But then you flip the page to an article about, I don't know, quantum physics, and you just accept it because it sounds authoritative. That is exactly what happens with LLMs. They sound incredibly convincing, right up until they start talking about something you know inside and out. Yeah, that veneer of confidence can be pretty thin. So if an AI's whole game is just predicting the next plausible word, what happens when it needs to do something that requires actual logic, a sequence of steps, you know? How does it plan? The thing is, the real world is filled with tasks where the order of operations is everything. Think about building IKEA furniture or following a recipe. One step out of order and the whole project is a disaster. It's this idea that actions interact with each other, where a pure next word prediction model just completely hits a wall.
Let's use a ridiculously simple example. How do you get dressed? It's obvious, right? Step 1, you put on your socks. Step 2, you put on your shoes. The order is critical.
But here's the problem. An LLM doesn't understand critical. To the AI, putting on shoes and putting on socks are both just highly plausible steps related to getting dressed. It has no grasp of the real-world consequences. So what happens if it just spits them out in the wrong sequence? The whole plan fails. If you put your shoes on first, you are physically blocked from putting your socks on. That's an interaction. The first action makes the second one impossible. A system that's just generating plausible text has no way to understand this simple physical fact. It can't reason about cause and effect.
So, if these standard LLMs are so bad at reasoning, how in the world are some AIs solving those insane math problems we started with? The answer isn't some magical, smarter AI brain. Nope. It's just some really clever engineering. The big breakthrough was to build a system with two distinct parts. You keep the creative, storytelling part of the LLM, we'll call that the generator. But then you pair it with a second component, a logical verifier. And here's how this tag team works. The generator, our LLM, does what it does best. It makes fast, creative guesses, and it's great with style. Then you have the verifier. This is usually just good old-fashioned logical computer code. It can't guess or be creative, but it is ruthlessly logical. Its only job is to check the generator's work and say, yep, that's correct, or nope, that's wrong. They work together in this really slick loop. First, the LLM just generates a potential solution. It throws something at the wall. Then the verifier tests it. If the answer is wrong, that feedback, that critique, gets added right back into the prompt. So the LLM gets to try again, but this time, it's a little smarter because it's learned from the verifier's feedback. It's just this constant cycle of generate and test over and over until the verifier finally gives it a thumbs up. This two-part system is a huge leap, a total game changer. And what's really profound about it is what it allows AI to access for the very first time. It unlocks an entirely new category of human knowledge. For a long time, AI could really only learn from the text and images we've uploaded to the internet. But this new model gives it a key to a completely different library. So standard LLMs learn from our declarative knowledge. That's the what, the facts, the articles, the poems online. But these new reasoning models can also learn from our procedural knowledge. That's the how, the logic, the computer code, the verifiers we've built that know how to check if a process is right or wrong. And as Professor Kambhampati says, the results of this is just astonishing. By combining the what and the how, these models are effectively putting the sum total of all of humanity's recorded knowledge right at our fingertips. So in the end, this makes AI an incredibly powerful mirror. It reflects back to us everything that we, as a species, have already figured out and written down. It operates inside what you could call humanity's knowledge closure, the boundary of everything we currently know. And that, of course, leaves us with the ultimate question. These systems are becoming absolute masters at synthesizing and combining the knowledge we already have. But can a system that's designed to be a perfect reflection of what is known ever take that next leap to discover something entirely new, something we don't know yet? Well, that is the real frontier.